हाँ तो ये क्वेश्चन है फाइंड kth rotation. Um, so this question is quite simple. You are given an increasing sorted rotated array of distinct integers. The array is right rotated k times. You need to find the value of k. So suppose you are given 2, 4, 6, 9, and if you rotate it 2 times, so 9 will come in the first position, then 6 will come in the first position, and it will become 6, 9, 2, 4. So essentially, let's start with their example. So if I have an array like 5, 1, 2, 3, 4, so you can see that this array is right rotated one time. How can we say it's right rotated one time? Because earlier this array was 1, 2, 3, 4, 5, and you made 1, 2, 3, 4, 5, and you right rotated it. So this 5 went to the first position, and this array became 5, 1, 2, 3, 4. So we'll say that this array is right rotated one time. So essentially this is what it means. Suppose you're given something like 5, 6, 7, 8, 0, 1, 2, 3, 4. Now how many times is this rotated? Now you know that initially the array was in ascending order. So you just write the array in ascending order. So you write something like this, and then you say, okay, I'll bring 8 I'll bring 8 to the front, then I'll bring 7 to the front, then I'll bring 6, then I'll bring 5. So this array, you can see, is rotated four times, because at this position there's a discrepancy. So it's increasing here and it's increasing here, but it's decreasing here. So you can say that this array is rotated 4 times, because you are rotating it one by one. You're bringing the last element to the right one by one, right? Now you need to figure out that if I give you any kind of an array, you need to figure out how many times is it rotated by in log n time complexity. So how do we do that? So before log n, let's see how do we solve this question in O of n time complexity. So how would you solve this in O of n time complexity? Now you need to think of a very simple thing, and that simple thing is that whatever the position of your largest element is, that position is the number of times that you have rotated the array. Now, why is that true? So suppose you have an ascending array, right? Your starting array is always in ascending order, that is given to you. Now, what are you doing is, when you're right rotating it, you're putting the current largest element, and placing it in the first position. So you shift 8 to the first position. Now 8 comes here. Now what you're doing is that you're shifting the current largest to the first. So 8 gets shifted 1 to the right, then 8 gets shifted 1 to the right. So similarly, um, so in this array you can see that the array is rotated by 3 times, because this 8 has been shifted 1, 2, 3. So the number of times this 8 gets shifted is the number of times you have rotated this array. So I hope you get the intuition behind it. So essentially the number of times you have rotated this array will be the index of 8, or index of the largest element of the array. So yeah, that's what you have to find out. So in O of n, how this will work is like, suppose you're given an array, you'll start from index I equals to 0, and you'll keep traversing until you find the max element and return the index plus 1 of the max element. Now as they have asked us to do this in log of n time, obviously you're going to use binary search here. So the question is, how do we use something like binary search in this question? So okay, what is the concept behind binary search? In binary search, you have to reduce the search space by half in every iteration. So how do you reduce the search space such that you'll be able to find the largest element in a rotated sorted array? So now our question becomes something else. Our question becomes how to find the maximum element in a rotated sorted array in log n time. Now this is your question. Now how do you solve this question? Okay, so here's the intuition behind it. Suppose you're given an array like this, right? And okay, let me just rearrange this stuff. Let me put the start pointer in the starting itself. Let me put the end pointer, and let me put the middle pointer. Now as you can see that the middle element is less than the end element. There can either be two cases. There can either be two cases. Either the middle element is less than the end, or the middle element is greater than start. So if the middle element is less than the end element, then that means that your array is right sorted. And if your middle is greater than start element, that means that your array is left sorted. So how is that possible? Let's see. So in the first example, your middle element is less than the end element. That means that this part of the array is sorted in ascending order, and this part is not. So if you know that this part is sorted, you can always say that the largest element in this part is going to be a candidate for your maximum element. So I'll declare a variable maxi and I'll store it there. So here, so my maxi will be 5 at first, right? So after I do that, I know one more thing, that I found the largest element of the right sorted array. Now I don't need to deal with the right sorted array anymore. So what I can do is I can explore the left sorted array. So I'll put my end as middle -1 and my new middle will become something like 7, right? Now I'll say, okay, my middle is greater than start, and this becomes my left sorted array. So in this left sorted array, I'll say 7 becomes a candidate for my maximum. So this becomes a candidate and I store 7 because this was left sorted, right? And I'd say, okay, I'm done with this part of the left sorted array. Now let me go back to the right sorted array. So I'll make my start as mid +1, and now my maximum becomes 8, right? So like this, you get the intuition behind how you can do binary search in such that you're reducing the search space by half every time, and using the property that if an array is left sorted or right sorted, using that you can easily find the middle element in log of n time. And when you find that, you just have to return the index +1. So yeah, this was a very simple approach. I'll show you the code if you want. Essentially, you initiate start, end, and middle just like you do in binary search, and you traverse while start is less than equal to end. So you find out the middle. If the array of middle is greater than equal to array of start, then you know that the array is left sorted. So you store the maximum element and you go to the right sorted part, and if the array is right sorted, then you go to the left sorted part, and at last you return maxi +1% array dot size, because you have to return the modulo of the thing. It can only be rotated from 1 to k times, not more than that. So yeah, that's it. That was a pretty simple code. Yeah, I think that's a pretty optimal solution for this question. Thank you.